right, guys, so we're continuing looking at graphing quadratic equations. And so where we're going to go in now is actually graphing them. In 110, you are going to spend some time looking at transformations. What do all of these numbers in vertex form? What do they tell you to do? So I like to put this here because I just think it's useful to have for when you go to 110. Here in Math 102, though, we are going to graph with a table. So we are going to pick some points for X and Y, and then we are going to plot those points on the graph, and that's how we're going to get our graph. We're not going to use the transformations. I just like to show you that so that when you get into Math 110, if you want to go back and pull these notes up, you can. So here's our first example out of your homework. It says, consider the following equation, y equals x squared minus 4x plus 5. All right, so first thing I'm just going to make a note of is that this thing is in standard form. And standard form is my normal ax squared plus bx plus c. That's what we've been doing for a while up to now. Step 1 in Hawks is going to say rewrite the quadratic function in the form that. That is vertex form. And so you have two options. Vertex form, to rewrite in vertex form, you can either find the vertex and plug it in, or you can complete the square and then that will give you the vertex. And so I'm going to do it both ways because you need to know how to do this to complete the square going forward for Math 110, just because you will take problems that are more complex than the ones we're looking at in 102. So if you were going to complete the square, you would have to set up your problem so that you had the two blanks on the same side as the equal sign. So what we did when we completed the square, we added the number to both sides to keep that equation sign balanced. Well, because we don't really have another side, we have just that y over there, not a number now, not 0. We're going to have to do a little bit finagling with the math end of it. Now, the complete the square part is going to be the same. We're going to take b and divide by 2 and square it. So negative 4 divided by 2 and squared, which is going to give me negative 2 squared, which is 4. Okay, I'm going to add that thing to both sides. Now, in this case, there aren't really both sides. So if I add 4 here, I have to subtract 4 here. Because really, plus 4 and minus 4 is just 0. So I've essentially added 0 over here, but I have to rewrite it in a certain way to kind of get creative, essentially. Now I'm going to finish completing the square on this part so that I can set up those parentheses for my vertex form. And so it was always x and the number before I squared it, squared. And then over here, 5 minus 4 is going to give me 1. And so there I have gotten my vertex form. Now I can pull out my vertex, which I'll need that in step 2, and off I go. The other way, if you want to find the vertex using the formula and then put it back in, you can do that method too. So let me show you that. If you wanted to find the vertex, we would do, like we just did in the last video, b divided by 2a, negative b divided by 2a. So that I'm going back to this thing right there. Okay, so negative b, going back over here, negative 4 is going to be a positive 4 over 2 times a, which is 1. 4 divided by 2 is going to give me 2. That's going to be my x value. And then step 2, plug in the 2 to the actual equation. 2 squared minus 4 times x, but x is 2, plus 5 is going to be 4 minus 8 plus 5, which is going to give me 1. Okay, and you could put that whole thing in your calculator. Now, that is not the answer. The question said rewrite it in the vertex form. And so I would have to take those two things, the x and the y value, or h and k, they mean the same thing, and I'd have to plug it into y equals a times x minus h squared plus k. Well, in this one, a is 1, and so a is still going to be 1 here, so I'm not going to bother with writing that at all. Y equals x minus h is the, get the right color, h is the x value, which is 2. Now I have that minus sign as part of the equation, so I can't change that. So I've got x minus 2 squared plus the y value, which is 1. And that should be plus 1. So I get the same thing. I truly think complete the square is easier, but you do have to remember this little trick about adding 4 and subtracting 4 to make sure we keep that thing balanced. But you do have two options, and I don't particularly care which way you do it, but you do have to do one of them because you need to get vertex form. Now, step 2 says, okay, well, find the vertex. Well, I found the vertex over here, but had I not done that method, I would be able to pull my vertex out of vertex form. That's the whole point of it. And so the vertex, if you use vertex form, change h, change the sign, so that's going to be 2, keep the sign of k, which is 1. Or, had you done it over here, we got the x value is 2, y value is 1. You would just write those down. And then step 3, find the number of zeros, if any, to this function. So zeros are going to be where the graph crosses the x-axis, but you learned way back in Math 101 that to find the zeros, you are going to set y equal to 0. And so to set y equal to 0, I have this thing, x squared minus 4x plus 5 equals 0. And I can solve that with any of the methods I've learned. So to solve a quadratic, we can factor, which is always going to be the easiest. Quadratic formula, which is probably the next easiest. And then complete the square, which is probably the last easiest. I always recommend try factoring first just because it's so much quicker. If it doesn't factor, or if you can't quickly see the factor, then go to quadratic formula. But this one does factor pretty nicely. So I'm looking for, if you remember back to chapter 13, two numbers that multiply to a times c, which is 5, and add to 4. And so I have 5 and 1, negative 5, or sorry, positive 5, negative 4. However, that would not add, or sorry, that would not multiply to 5. That would multiply to negative 5. And so actually this one does not factor like I thought. So I have to go to quadratic formula. So step 1 in quadratic formula was b squared minus 4ac. And so we can type that thing into our calculator and get -4, which tells me that that's going to give me 2, we wrote non-real solutions. And so I can stop right there because the question said find the number of real zeros. And this just told me I get 2 non-real solutions. So the number of zeros I'm going to get, the number of real zeros I'm going to get is none. Because of my 2 solutions, they are both non-real. Remember, we looked way back when we talked about the discriminant, that chart back from 16.3. You're going to get 2 solutions for a quadratic. The 2 solutions are either going to be 1 real, and it's going to be the same number repeated, like 5 and 5. 2 real, or 2 non-real. And in this one, I have 2 non-real solutions, and I see that from the discriminant because it's negative. So the number of real zeros I'm going to get is none. And then the last part of this, step 4, graph the quadratic equation by identifying 2 points on the parabola other than the vertex. So when I set up my chart, I go ahead and put the vertex in there because it's going to make it a little bit easier to find one to the left of the vertex and one to the right. Now, you can't type the vertex into Hawks because it's already been accepted way up here in step 2, but I use it in my chart just so I can visualize what's going on. So the vertex was 2, 1. And I'm going to go ahead and graph that just so I have a visual. Now, what you're going to want is 1 point to the left of the vertex, 1 point to the right of the vertex. The easiest thing to do is just go 1 spot to the left, and that would be 1. And 1 spot to the right, that would be 3. That's going to be the easiest way. You can always do that. To find the y values, I now need to plug it in. I would recommend plugging it into standard form because it's a little bit easier to work with in terms of you can just type in your calculator without all these parentheses. So here's my standard form. Y equals x squared minus 4x plus 5. And so what I'm going to do for this first line, I'm going to fill in a 1 everywhere I see an x. And so I'll have 1 squared minus 4 times 1 plus 5. I'm going to just evaluate that. And that's going to give me out a y value of 2. And that's my first point, the 0.12. My second point, I'm going to do the same thing, except now, instead of typing in y equals 1, x equals 1, I've got x equals 3. So I've got 3 squared minus 4 times 3 plus 5. And I'm going to evaluate that and get out y equals 2. And so now I'm going to plot this. My 2 points are going to be the 0.12, and so go right 1, up 2. And the 0.32, go right 3, up 2. Now, we don't know any other points, but all of these are going to have a nice curve. Oops, I missed my point. A nice curve in the bottom. They are not going to be straight and pointy. They're going to come through and make this U shape. All of these will be U shaped, nice and rounded. That's part of the definition of a quadratic equation, is it's going to all have the same shape. Now, they may be flipped upside down, they may be slid over, up, down, but they will all have this same U shape.